Okay, this video we're going to be talking about factoring um, with an a value that is not 1. We're also going to be talking about factoring differences of squares. We're actually going to tackle it both at the same time. Previously, we've been factoring quadratic functions where the value in front of the x squared is 1, like it is here. Just for a simple one, for instance, we'd find factors of 2. That would add up to 3. And then we'd just factor by grouping. Right? And we'd pair them up, find the GCF. And get x plus 1 times x plus 2. Now, the type of problems we're going to do is where the value in front of x squared is present. It's a number greater than 1, right? So for the first example, we're going to do y equals 4x squared minus 0x minus 9. Now, we're still going to try to find factors that add up to the middle term, which here is 0, but instead of just using the last digit, we're going to multiply 4 times negative 9. We'll get negative 36, and then we're going to find factors of negative 36 that add to 0, okay? Things like 12 and negative 3, or 6 and negative 6. 6 plus negative 6 is 0, so we're actually going to use those two. 6x minus 6x minus 9 and 4x squared. Okay, and then we're just going to go through the same process. We're going to pair them up, take out the GCF, so in this case it's 2x, and we're left with x plus 3. Here we need to make negative 6x minus 9 equal to x plus 3 by factoring a number out. X plus 3 is both positive, so we need to factor a negative term out to make everything positive. So we're going to factor out a negative 3, and we'll be left with positive 2x plus 3. Now you see how the groups are both the same. So our factors now will be y equals 2x minus 3 times 2x plus 3. Where one of our factors comes from the group and the other factor comes from what's left over. Now, the second example, we're going to do y equals 25x squared plus 0x minus 4. Again, we're going to multiply the digit in front of the x squared, which is 25, times the last, which is negative 4. And we're going to get negative 100. And then factors in negative 100 that add up to 0 are going to be 10 and negative 10. So we're going to rewrite the middle term. 25x squared plus 10x minus 10x minus 4. Okay. From here, pair everything up. Take out the GCF, which is 5x. I'm left with 5x plus 2. Now I need to get negative 10x minus 4 to be 5x plus 2. I'm going to do that by factoring out a negative 2. And I'll be left with 5x plus 2. So here, my factors will be 5x minus 2 times 5x plus 2. Now, if you notice, on both these problems, our middle term is 0, so I could technically rewrite the first example as 4x squared minus 9, and the second example as 25x squared minus 4. Okay. Now, the reason why I didn't write them this way originally is because we're used to seeing an x term in the middle, which is very important here. Whenever you don't see an x term in the middle, we're looking for a 0. But also, whenever we look at these, These are called differences of difference of squares. Okay, difference being there's subtraction, and then squares being there are numbers that are squared. For instance, 4 equals 2 squared. And if you notice, we have 2x and 2x, and then we have a 4x squared. Okay. So if I was to do number 1 based on a pattern of squares, I know the square root of 4x squared is 2x, and then the square root of 9 is 3. So my first factor would be 2x plus 3, and because I need a negative, I'll use the other factor to write it the exact same way, but with a negative sign. And then for number 2, our second example was y equals 25x squared minus 4. The square root of 25 is 5. Square root of x squared is x. Square root of 4 is 2. So 5x plus 2, and because we have a negative 4, it'll be 5x minus 2 as well. And it's that easy and that quick. Another example is just like x squared minus 16. Okay. Again, square root of 16 is 4. Square root of x squared is just x. So our answer will be x plus 4, x minus 4. Another example, y equals x squared minus 49. Square root of x squared is x. Square root of 49 is 7. And then we need the negative version as well. It's a difference of squares.